So in this video we're going to continue our discussion about graphing trig functions. Here we're going to graph the cosine function. So just like before when we talked about the sine function, we're going to animate this point around the unit circle. And where the red line represents the y value, the blue line, or the blue line segment rather, is going to represent the cosine value or the x value. So if we start to plot these x values in relation to the radians as the point goes around the unit circle, we start to see this graph here. And it looks very similar to the sine graph. However, it's just translated a little bit over. So it's easier to see when you have more than just a single period here. But this cosine graph is going to have a maximum value here, a minimum value here, and it's going to come back to its maximum right there. We know that the cosine is going to be 0 at pi over 2 because the x value right here is 0. It's also going to be 0 at 3 pi over 2 because the x value right here is 0. We have our minimum right here at pi because the x value is going to be -1 when we've gone pi radians. And we're going to have maximums at 0 and at 2 pi because at both of those right there, the x value is the maximum +1. So the general form of a cosine function is very similar to the general form of a sine function. We have f of x is equal to a times the cosine of b times x minus c plus d. And a, b, c, and d all have the same influence on the graph as they did with sine functions, where we have the amplitude is represented by a. Remember, the amplitude is how far up or above or below the midline the graph will go. We have b is equal to 2 pi divided by the period. And again, just like with the sine, if I want to know the period is still going to be 2 pi divided by b. All right, because the cosine, just like the sine, has a period of 2 pi. The value c is going to be the phase shift, how far left or right it moves. And then the value of d is going to be the vertical shift, how far up or down did we move our midline. All right, and again, we can look on the website at desmos.com, and here I've got the cosine, a times the cosine of b times x minus c plus d, and we can play with the sliders and see that that's still true. So we can see that a here is going to increase the amplitude, right, but not the frequency. We can see here that b is going to increase the frequency if I make b bigger, or decrease it if I make b smaller. We can see that c is going to be our horizontal shift. It's going to move our graph left or right, depending on the sign and the value. And we can see that d is going to move our graph up and down, again, depending on the value of the midline. So let's say once again we have an example that we want to deal with. So here we have 4 times the cosine of 2 times x minus pi over 4 plus 3. So the first thing we always have to do is we have to identify a, b, c, and d and what they represent on the graph. So the first thing here is I know that my amplitude is going to be 4. I know that my value of b is going to be 2, and that means that my period is going to be 2 pi over 2. So my period is really just going to be pi in this case. So that means, remember, that's important for the scale, because now I know that when I'm coming over to do my scale, the scale of my x-axis is going to equal the period pi divided by 4. So every time I make tick marks over here on my scale, this is going to be pi over 4. This part here is going to be 2 pi over 4, which is the same as pi over 2. This next one here is going to be 3 pi over 4. The next one here is going to be 4 pi over 4, which is the same as pi. And then the next one here would be 5 pi over 4. And we can do the same thing the other way. That would be 0. This would be negative pi over 4. This here would be negative 2 pi over 4, or negative pi over 2. This would be negative 3 pi over 4, and we'll go all the way over here to negative 4 pi over 4, negative pi. So the scale just kind of helps me set up my x-axis and figure out, well, what do I want to count by on my graph, so that's going to end up making sense and being easy to deal with as we move on. So the phase shift here, we have a pi over 4 units to the right, and our vertical shift here is up 3. All right, so that means that when we go to draw our midline, the first thing we want to do is go up 3 units and draw our midline right across. So normally, the cosine function, we go back to this example here, normally the cosine function starts at 0, 1, or at the maximum value, its amplitude above the midline. Okay, so for this case here, normally we'd be starting at 0 and then the amplitude, so our amplitude is 4, so we might think, okay, we're starting at 0, 4 units above the midline, but remember we had a phase shift over here of pi over 4 units to the right. So instead of starting at the midline going up by our amplitude, we actually have to move over to the right pi over 4 units. So our first point is going to be pi over 4 and then 4 units above the midline. Since the midline is at 3, that means that our first point right there is pi over 4 comma 7. Now cosine starts at the maximum and then begins to dip. So our next critical point is going to be back here at the midline. Then we're going to have a minimum, so we're going to go 4 units down, so we're going to have a point right there. And then we're going to go back to the midline, and we're going to go 4 units up right here. Okay, so our graph tends to look like this. So excuse, so let's see if we can draw that a little bit better here. Comes down. Something like that. Close enough. If we wanted to keep the graph going, we simply continue adding our critical points here. So we come down here to 0. We would bounce off here, come back up. So we're just going to have this continuous wave just like this. And if we go to Desmos.com again and we put these values in, we should see that our graph will look just like this. So we can actually just type these in. We'll say, okay, A was going to be 4. B, we wanted to have a value of 2. Our value of C was pi divided by 4, and our value of D was 3. And so this is what our graph here would look like. You can see that the minimum value there is 1 in most cases, just like our case here, right? Our minimum values were at -1. You can see that the maximum value up top is at 7, right? Right here is 7, which is the same as what we had right here. And then the critical points, which we see here, 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 here on the midline, are going to be coming at 0, at pi over 2, at pi. And if we look back here, we have one here at 0. We have one right here at pi, and then again over here at 2 pi. Or pi over 2. So that's an example of how you graph a cosine. Okay, so the biggest difference between a cosine and a sine is just that it's shifted. In other words, the sine and the cosine, they have the same general shape. Right? You can see the same shape here in a cosine graph as you can in a sine graph. The only difference is where they start. So the cosine usually starts at the maximum point or the midline plus the amplitude, whereas in the sine graph it starts right on the midline, increasing. In my next video, I'm going to show you how to come up with a sine and a cosine graph that look the same. Okay. Good luck with your graphing, and check back for more videos later.